Unless you've been stranded on a desert island, such as happened to the guy in New Zealand on the South Island. He's been walking one of the famous coastal trails. So he's been 2 months on his own, and when he went in, COVID didn't exist, and when he came out, COVID-19 had basically shut New Zealand down. So he was supposed to be getting on a flight, but New Zealand was isolated from the rest of the world. So COVID-19 is a very nasty little virus. It's wreaked havoc throughout the world, and it's particularly wreaked havoc in the United States. COVID virus type epidemics occur reasonably frequently, probably about every 10 to 20 years. They're not as atypical as people would like to think they are. It's been almost 100 years since we had the 1918 flu, which got to this level of deaths in some parts of the world. In 1927, McCormack invented a mathematics for studying epidemics. He developed a set of equations which basically took a population which was uninfected and susceptible and worked out how to determine how many people were likely to be infected at any particular time, and also how long would it take before the population got to the point where they had herd immunity. So even if you've got 100% susceptible population, you're not going to kill all of them because they're all not going to become infected. It's the chances of you interacting with someone else who is infected and then you get it, and then those chances change with time. So when the first infected person comes in, there's an entire population, and as soon as he runs into a person, they become infected, so now you've got 2 infected people. And so it becomes the law of diminishing returns. Once you get to about 70% of the population, you're starting to get to the level of herd immunity. You're going to have a falling off in the number of people who are going to continue to be infected, and the number of people who are going to die. The problem with McCormack in 1927 developed these formula, and they've been used pretty consistently since that time. They have made some minor changes to it, but not major changes. They introduced some new categories, so we have the category of susceptible people. That's someone who hasn't been exposed to the virus. Of course, we have the problem that there will be some people in that group who have a natural immunity to it just because of some other random event. And so even if we had an entire population that's exposed, they're not all going to die. This is essentially how particular sets of genes spread through the population. We have an exposed population, something comes in and triggers a death, and the gene that saves them becomes dominant within the population. We see that with the introduction of the gene which looks after the ability to drink milk and digest cow's milk. The difficulty with the COVID virus, with our ability to collect very fine statistics very quickly, is we now have a daily death toll. The only problem with the daily death toll for the COVID virus is that we have someone die. We need to know what day they actually died on. Did they die on a Sunday? Or is it 4 or 5 days before the death is reported and put into the statistical system? So in the beginning, COVID virus wasn't recognised as something that was killing people. It took a while for the death statistics to catch up. But now we have a reasonably good set of death statistics going along on a daily basis. Once you get a daily set of data, we then move into a different set of mathematics. We can start to look at the variations in the daily pattern. The assumption was that there's no pattern underlying this, that the overarching ordinary differential equation basically gave us a smooth curve and we just had random noise on top of that. Well, analysis using fast Fourier transforms, which break that noise into its patterns, means that we can now look at the daily pattern. And so we now know that there is a weekly pattern in the deaths. Deaths are lower at a time when humans are resting and relaxing, like at weekends in the Western world, in other parts of the world where this occurs on Thursday and Fridays, the same thing happens. So we now see that there is a pattern to this, and the pattern is really quite dominant, and we're seeing it in the United States. So this pattern is going to become something which needs to be included in future COVID modelling.